Let's do a quick intro to acid-base status and its interpretation. When we're talking about acid in the body, in terms of acid-base status, we're talking about hydrogen ions. Yes, there's lots of acid going on in your body, but what we're buffering, it's going to be a product of just metabolism, and cellular metabolism. Those are the hydrogen ions, and how we're buffering that is primarily through the lungs and our kidneys. The more hydrogen we have in our system, the lower our pH is going to be. So the more hydrogen, the more acidic we are, so that pH number is going to go down. And then the less hydrogen we have in our system, the less acidic we're going to be, the more alkalotic we're going to be. So when that pH rises, we're going to go into an alkalotic state. The more hydrogen we have in our system, the lower our pH is going to be. So the more hydrogen, the more acidic we are, so that pH number is going to go down. And then the less hydrogen we have in our system, the less acidic we're going to be, the more alkalotic we're going to be. So when that pH rises, we're going to go into an alkalotic state. If you remember all your wonderful chemistry, here's a great formula for you. We can go left to right, or we can also go right to left with this formula. So we've got our hydrogen ions right here, our acid, right? So we can combine hydrogen with bicarbonate, that HCO3, turning that into H2CO3, which is carbonic acid, and that can break down into just water and carbon dioxide. Remember, carbon dioxide we can just breathe off, right? We can also go the other way, right? We've got carbon dioxide combining with water in our body, making that H2CO3, that carbonic acid, which then, if we're going right to left, can be broken down into hydrogen ions and HCO3, that bicarbonate. So in our lungs, we're buffering this acid with our lungs, and we can blow off carbon dioxide, right? We can blow off carbon dioxide. We can also retain carbon dioxide. Same thing with our kidneys. We can either retain bicarbonate, or your kidneys can excrete bicarbonate. If you remember all your wonderful chemistry, here's a great formula for you. We can go left to right, or we can also go right to left with this formula. So we've got our hydrogen ions right here, our acid, right? So we can combine hydrogen with bicarbonate, that HCO3, turning that into H2CO3, which is carbonic acid, and that can break down into just water and carbon dioxide. Remember, carbon dioxide we can just breathe off, right? We can also go the other way, right? We've got carbon dioxide combining with water in our body, making that H2CO3, that carbonic acid, which then, if we're going right to left, can be broken down into hydrogen ions and HCO3, that bicarbonate. So in our lungs, we're buffering this acid with our lungs, and we can blow off carbon dioxide, right? We can blow off carbon dioxide. We can also retain carbon dioxide. Same thing with our kidneys. We can either retain bicarbonate, or your kidneys can excrete bicarbonate. Thinking way back, we all learned that perfect neutral pH is 7. Well, our blood pH, our body's pH, is pretty close to 7, but just a hair above. So our normal arterial blood pH is going to be 7.35 to 7.45. It's our normal range. Anything lower than that, lower than 7.35, is going to be an acidotic state. Anything greater than 7.45 is going to be an alkalotic state. And yes, we are going to be looking at that, not only the 10th, but the 100th decimal place, right? So 7.35 is our low end for our normal range. Even if you go 7.34, 7.33, it might not sound like a lot, but to the body, it is. So even at 7.34, you are going to be in an acidotic state, and the body is going to start to react accordingly. Thinking way back, we all learned that perfect neutral pH is 7. Well, our blood pH, our body's pH, is pretty close to 7, but just a hair above. So our normal arterial blood pH is going to be 7.35 to 7.45. It's our normal range. Anything lower than that, lower than 7.35, is going to be an acidotic state. Anything greater than 7.45 is going to be an alkalotic state. And yes, we are going to be looking at that, not only the 10th, but the 100th decimal place, right? So 7.35 is our low end for our normal range. Even if you go 7.34, 7.33, it might not sound like a lot, but to the body, it is. So even at 7.34, you are going to be in an acidotic state, and the body is going to start to react accordingly. Now, when it comes to interpretation, and what are we looking at? What are we seeing with this arterial blood gas, with these numbers coming back to us? Well, first off, we're going to start right up here. Is there a problem? We're going to look at pH. So is there a problem with the pH? Is it too high? Is it too low? Or is it just right? So going back to our normal range, 7.35 to 7.45, is it outside that range? If it's less than 7.35, we're in some sort of acidosis. If it's greater than 7.45, we're in some sort of alkalosis. And from there, we can start to look at carbon dioxide levels and bicarbonate levels to see where the problem is. Right? Once we've identified where the problem is, right, is it an acidosis, is it an alkalosis, and who's the main culprit? Right? Is it carbon dioxide, or is it bicarbonate? Right? Is it too high, too low? And then we'll get into the respiratory and the metabolic sides here in just a couple minutes. Now, when it comes to interpretation, and what are we looking at? What are we seeing with this arterial blood gas, with these numbers coming back to us? Well, first off, we're going to start right up here. Is there a problem? We're going to look at pH. So is there a problem with the pH? Is it too high? Is it too low? Or is it just right? So going back to our normal range, 7.35 to 7.45, is it outside that range? If it's less than 7.35, we're in some sort of acidosis. If it's greater than 7.45, we're in some sort of alkalosis. And from there, we can start to look at carbon dioxide levels and bicarbonate levels to see where the problem is. Right? Once we've identified where the problem is, right, is it an acidosis, is it an alkalosis, and who's the main culprit? Right? Is it carbon dioxide, or is it bicarbonate? Right? Is it too high, too low? And then we'll get into the respiratory and the metabolic sides here in just a couple minutes. Now, once we've determined, yes, there is a problem, there is something going on with this pH, it's outside our normal range, start looking for the culprit. Is it respiratory? Is it metabolic? Is there something going on with either side? So let's start with the respiratory side. Now, once we've determined, yes, there is a problem, there is something going on with this pH, it's outside our normal range, start looking for the culprit. Is it respiratory? Is it metabolic? Is there something going on with either side? So let's start with the respiratory side. Going back to our lovely formula, again, we can go left to right or right to left, either way. But here, with the respiratory side, we are talking about carbon dioxide. So respiratory side, think your lungs. What can we do with our lungs? We can either retain CO2 or we can blow off CO2. So it's really reflected with that CO2 level and our CO2 level in the arterial blood. What our normal range is, 35 to 45. That's our normal range, so 35 to 45. Any derivation thereof is going to be off. Anything greater than 45 is going to be an acidosis. Anything less than 35 is going to create an alkalosis. So when you think about it, carbon dioxide levels, when they go up, they cause the pH to go down. And when CO2 levels go down, it causes the pH to go up. So carbon dioxide levels and pH levels move in opposite of each other. So first, let's look at respiratory acidosis. So we're in an acidotic state, and it's due to some sort of respiratory process. Might have some sort of hypoventilation going on. Either the patient is not breathing fast enough or deep enough, right? So there is some sort of poor exchange of carbon dioxide, and there is carbon dioxide retention, right? We'll also see this in asthma patients, COPD patients, right, where they're just retaining this carbon dioxide. And while that carbon dioxide level goes up, the patient becomes hypercarbic, that CO2 level is going above 45, that's putting that patient into an acidotic state. So again, as the carbon dioxide levels rise, pH goes down and becomes acidotic. For example, you've got an asthma attack patient, right? patient with history of asthma, something flared it right here in the moment. They go into an asthma attack, right? They're going to have some shortness of breath, right? They're going to have some wheezing. What they are doing is retaining carbon dioxide. They're having a hard time blowing off carbon dioxide, having a hard time with expiration. So they're retaining carbon dioxide. So for this patient, if we were to pull an ABG right on the spot, we've got a carbon dioxide level of 60, which is greater than our normal range of 35 to 45. So we're definitely hypercarbic. It's a high CO2 level. Our bicarb level, I just threw that in there, 25. We haven't gotten to normal levels quite yet, but that's within the normal level. So our bicarb level is normal, our CO2 level is high, and our pH 7.3. It's definitely lower than our normal range of 7.35 to 7.45. So this 7.3 should put a 0 in there. 7.30 is low, and our CO2 is high. So with that CO2 being high at 60, that is pulling the pH down, creating an acidotic state for this patient. So this asthma attack patient is in a respiratory acidosis. On the other side, a respiratory alkalosis, think hyperventilation. You have a patient who's breathing far too quickly and is blowing off a lot of carbon dioxide. Right? Still might be complaining of shortness of breath. You've got a hyperventilation patient, maybe an anxiety attack, right? This acute anxiety in the moment, start hyperventilating. Now we've got a CO2 level of 20, far lower than our normal range of 35 to 45, and we have a pH of 7.6, much higher than our normal range of 7.35 to 7.45. So got a pH of 7.60, a carbon dioxide level of 20. So as that carbon dioxide level goes down, the pH level is going to go up and create a respiratory alkalosis. That was a quick intro to the respiratory side. Now let's jump over to the metabolic side. And with that, now we're on the left-hand side of our formula with that HCO3, the bicarbonate, which is mediated by our kidneys. And so we can reflect that acid by our HCO3, our bicarbonate level. Normal levels, it'll depend book to book and physician to physician that you talk to, but generally our normal range is going to be 22 to 26. Anything lower than 22 is going to be an acidotic state. Anything higher than 26 is going to be an alkalotic state. So unlike carbon dioxide, which moved in opposite directions of the pH, right? As carbon dioxide goes up, pH goes down, and vice versa. With bicarbonate, they move in the same direction. So as bicarb goes down, goes under 22, we go into an acidotic state, and as bicarb goes up, greater than 26, we go into an alkalotic state. So bicarbonate and pH move in the same direction. When it comes to acid-base status, metabolic acidosis can be a lot more common than metabolic alkalosis. So with metabolic acidosis, we're going to have a low bicarb level, a low HCO3 level. And if we look at the ABG here down at the bottom, we've got a patient in DKA, diabetic ketoacidosis. And we're going to call this uncompensated. There's nothing else going on. We're going to look at our carbon dioxide level, that's CO2 of 40. That is perfect, right in the middle of our normal range for carbon dioxide. But our pH is 7.2, and that's far too low, well outside of our range of 7.35 to 7.45. So our pH is low, 7.2. We're in some sort of acidosis. Now we look at our bicarb level, that HCO3. We find it at 8. Now that's far below our normal range of 22 to 26. So we have a low bicarb level and we have a low pH. Those two make sense together because as our bicarb levels go lower, the pH also goes lower. So in a DKA that hasn't started compensating yet, we have a low pH or an acidotic state, and we see that reflected in the bicarb level of 8. On the other side, with metabolic alkalosis, it is not as common as metabolic acidosis, and if we do find it, it is typically caused by medical providers and our medical treatment. Typically giving lots of sodium bicarb, right? If you give a couple amps of sodium bicarb, you're going to cause a metabolic alkalosis. There are some other instances like hypokalemia, or maybe a lot of nausea, vomiting, diarrhea that can cause metabolic alkaloses, but it's usually due to us. So with metabolic alkalosis, again, we look at our ABG. We've got a pH of 7.6, is higher than our normal range of 7.35 to 7.45, so we're in alkalotic state. Our CO2 level, again, a perfect 40, we love it. And then we look at our bicarb level. Our bicarb, our HCO3, is at 45, and that's far, far above our normal range for bicarb. So as that bicarb goes higher and higher, so does the pH, giving that our 7.6 reading and a metabolic alkalosis. Now we've mentioned acidotic states and alkalotic states being on their own, right? You might be in a metabolic acidosis or a respiratory alkalosis. Well, over time, when one side, the respiratory side or the metabolic side, when one side goes a little wonky, over time the other side is going to kick in and try to compensate and try to bring your pH back to normal. So perhaps it's a metabolic issue, primarily a metabolic issue, say metabolic acidosis. Well, the respiratory side over time is going to kick in and try to right the ship by bringing that pH back to normal. Same thing in the other direction. Maybe it's a respiratory issue. Maybe it's a respiratory acidosis. Again, over time, the metabolic side of your kidneys are going to kick in and try to bring that pH back to normal. So in this case, we're going to see a normal pH at 7.35 to 7.45, but with both carbon dioxide levels and bicarb levels being outside of our normal ranges. So here, when we're compensating, we are actually mixing acidosis and alkalosis. There's a primary culprit. Let's go with diabetic ketoacidosis, DKA. It is a metabolic acidosis. So our bicarb, our HCO3, is going to be low. That's the main culprit. So we have a metabolic acidosis. It's going to be compensated by the respiratory side. We're going to try to equalize a little bit. So the respiratory side is going to kick in, and what it's going to try to do is an acidotic state. It's going to try to pull that pH up back into the normal range, 7.35 to 7.45. And the way it does this is you're going to have this patient who is breathing fast and breathing deeply with those Kussmaul respirations. And the patient is blowing off carbon dioxide to lower their carbon dioxide levels. Your body's doing this automatically because, remember, CO2 and pH move in opposite directions. Right now I'm in an acidotic state. My CO2, I'm blowing off CO2, so my CO2 is low. That is pulling up my pH level. Because I'm in an acidotic state, my pH is low, I can blow off CO2 to pull that pH up. So we'll see these DKA patients who are in a metabolic acidosis compensating. Their body is compensating by blowing off carbon dioxide to try to pull that pH back up into our normal range. So here we've got a little bit of acidosis and alkalosis going on. We've got DKA, so we have a diabetic ketoacidosis, which is a metabolic acidosis. So the primary culprit is bicarb. The primary culprit is the metabolic side. So we see a HCO3, a bicarb level of 12. That's far too low. So that's going to put the patient into an acidotic state, pull that pH down, and then the body is going to automatically compensate by blowing off carbon dioxide. And it's that, so we see a carbon dioxide level of 20, and that low carbon dioxide level is trying to pull up the pH into a normal range, and here we've got that back in the normal range. The pH is 7.37. So we've got a normal range pH, but both carbon dioxide and bicarb are wonky. They're both outside their normal ranges. Well, which one, you might be asking, if we just gave you these numbers, CO2 and bicarb are both wonky. They're both outside the normal ranges. So which one is causing the issue and which one is compensating? That's the question. Well, quick and easy way to answer that. We've got a pH of 7.37. That's within our normal range. But it's on the acidotic side of our normal range. It's on the lower end. So if we put 7.4 as our perfect pH and our midway point right there, it's a little bit acidotic. Still normal, but a little bit on the acidotic side. So which of the two would make sense with a little bit acidotic pH? So we look at CO2, we look at bicarb. And if we look at CO2, CO2 is low. If it's low, pH should be high. We're on an acidotic side of normal. That doesn't make sense. Now we look at bicarb, at HCO3. We see a bicarb of 12. That's far too low. Bicarb and pH move in the same direction, so with a bicarb of 12, that should be acidotic. That makes sense with a slightly acidotic normal pH. So there we can state that it's a metabolic issue. That bicarb makes sense with that slightly acidotic pH level. And with that, it also makes sense that we are fully compensating with the respiratory side, with that 20 reading for our CO2. So we've got a metabolic acidosis compensated by a respiratory alkalosis. We have one more reading to throw into the mix for you. That is base excess. Base excess tells us about the metabolic side. So we can get into the formulas if we want, and we're not going to, but it gets into the metabolic side of our acid-base balance. A normal range is -2 to +2. So our perfect number there is just right in the middle is going to be 0. Should be somewhere around 0. And what base excess tells us, that number tells us, it's the amount of acid needed to bring that pH back to normal. So if it's a negative number, let's say it's -10. That means I need to take acid out of the system for the pH to be normal, which means I'm in an acidotic state. If the number is positive, let's say a +10, that means I need to add acid into the system to bring that pH back to normal. So if I need to add acid, that means that I'm in an alkalotic state. And base excess, again, tells us about the metabolic side. So it helps us confirm a metabolic alkalosis or a metabolic acidosis diagnosis. All right, you've made it this far. So some key takeaways. So we've got respiratory and we've got metabolic sides, we've got acidotic states, we've got alkalotic states. So if it's a respiratory acidosis, our CO2 is going to be high, which pulls down our pH. These are all uncompensated states, so our bicarb is going to be normal. If it's a respiratory alkalosis, again, CO2 and pH move in opposite directions. Our CO2 is going to be low, and that's going to pull up our pH, with bicarb being normal. If we go to the metabolic side, our CO2 levels are going to be normal, because it's a metabolic side issue, not a respiratory side issue. If it's an acidosis, our bicarb level is going to be low, and bicarb and pH move in the same direction, so that's going to pull down the pH, creating that acidotic state. If it's an alkalotic state, our bicarb levels will be higher, which will pull our pH up. Now all the things in one place. What is normal? Our pH, 7.35 to 7.45. Our carbon dioxide, 35 to 45. Our bicarb, 22 to 26. And our base excess, which tells us metabolic side only information, -2 to +2. On our acidotic sides, our pH is going to be less than 7.35, but our carbon dioxide, if that's the culprit, can be higher than 45, anything greater than 45. Bicarb, anything less than 22. Our base excess will confirm this with a negative number. On the alkalotic side, pH greater than 7.45. Carbon dioxide will be low, less than 35. Bicarb might be high, greater than 26. And our base excess, confirming metabolic alkalosis, would be a larger positive number. Let's try some out. Let's look at the top of this readout here. We've got a pH of 7.412. So think, is that too high, too low, or just right? That looks just right. It's within our normal range. It's a little on the higher side. It's not a perfect 7.4, but within our normal range. One down, our PCO2, partial pressure of carbon dioxide, is at 36.8. We can round that up at 37. Is that too high, too low, or just right? It is within our normal range of 35 to 45. It's a little bit on the lower end of normal, but we are okay with it. We're in the normal range. Let's move down past the PO2 to the HCO3, our bicarb, at 22.9. We can round that up to 23. And is that within our normal range, or is that too high, too low? And that looks to be within our normal range, right at 23. Again, at the lower end of our normal, but still within our normal range. One more going down, BE is our base excess at -1.3. So again, think, is that too high, too low, or just right? It is within our normal range for base excess, being -2 to +2. So it's a little bit on the lower end, again, of our normal range, but it is within our normal range. With this, if you want to dig into it, at pH of 7.412, it's a little bit on the higher side, a little bit on the alkalotic side of normal, and that CO2 is a little bit on the lower end of normal. This readout doesn't tell us, but I am guessing that this patient was breathing a little bit fast when this sample was taken, or whatever disease process, whatever is going on with that patient, they might be breathing a little fast. Is my general thought. I know nothing about this patient. Just grabbing a screenshot of an ABG printout here for you, but everything seems to be normal for our ABG readings, at least our pH, our CO2, HCO3, and base excess, all seem to be within our normal ranges. Here's another one for you. Let's look up at the top left. Our pH, we got 7.76. So is that too low, too high, or just right? That is far too high. We're definitely in an alkalotic state, 7.76, far above our normal range of 7.35 to 7.45. Let's move down one to our CO2 level, carbon dioxide level of 50. Is that too high, too low, or just right? That's a little high. So our normal range 35 to 45. So we have a high pH level. We have a high CO2 level. So think, does that make sense? If I have a high CO2 level, should my pH level also be high? And no, it shouldn't. That doesn't make sense. CO2 levels create an opposite movement in pH. So if my CO2 was high, my pH should be low. So that doesn't make sense. So we're going to move on for the time being. We're going to keep that in the back of our heads, but we're going to move on to our bicarb. So our bicarb is 70. HCO3 is 70. So is that too high, too low, or just right? That is far too high. That is very high. Outside of our normal range, 22 to 26, and it is sitting at 70. So we've got a high pH, a high CO2, and a high bicarb. So CO2 and bicarb are both high. They're both wonky. So which one's the culprit? Which one makes sense with that pH? The one that makes sense is bicarb. So my bicarb is high, and bicarb and pH move in the same direction. So as my bicarb goes up, my pH should go up. And that's what we're seeing here. Bicarb is 70, that's pulling the pH up to 7.76. What we're seeing here with the carbon dioxide is compensation. The respiratory side is trying to retain carbon dioxide as best it can to try to pull that pH back down to a normal state, normal level. So with that, it's trying to compensate. We haven't gotten there quite yet. pH is still 7.76, so we're not fully compensated. If we were fully compensated, that pH would be in the normal range of 7.35 to 7.45. It would be slightly higher than 7.4, but it would be in our normal range. Here, we're seeing compensation, but it hasn't corrected the pH issue quite yet, so we're in a partial compensation. So we've got a metabolic alkalosis with a respiratory acidosis, and that respiratory side is compensating. Let's take a look at one more. Up there at the top, pH is 7.33. So is that too high, too low, or just right? It's a little low. 7.33 is lower than our normal range of 7.35 to 7.45. And you might be thinking, well, it's just 7.33 versus 0.35. That's not much. But the body will react to that. It is very sensitive to your arterial pH. So 7.33 is on the low side. We are in an acidotic state. One more down, let's look at the CO2. CO2 level of 14. So is that too high, too low, or just right? It is definitely too low. Normal range 35 to 45. We're at 14. That's far too low. And now let's think, we've got a low pH and I have a low carbon dioxide level. Does that make sense? And no, it doesn't. Because as my CO2 goes lower, my pH should go up. So they move in opposite directions. A low pH and a low CO2 don't make sense. So let's carry on down here to the HCO3. It's a little further down. Let's go with the standardized HCO3 bicarb, 12.5. Now, is that too high, too low, or just right? So a 12.5 bicarb level, definitely too low. Outside of our normal range. So if I have a low bicarb level, does that make sense with a low pH level? And yes, that makes sense, because bicarb and pH move in the same direction. So as my bicarb goes lower, my pH decreases as well. So here we have a metabolic acidosis. Your metabolic side is the main culprit. Now, why is the carbon dioxide low as well? Well, here, again, we are compensating. So instead, your respiratory side is blowing off a lot of carbon dioxide, trying to raise that pH back into the normal range. We have almost gotten there at 7.33, just got a little bit of time to go. I bet give it like 30 minutes and redraw an ABG, and this pH will be back into the normal range. But this patient has a metabolic acidosis, and they have a respiratory compensation. They are blowing off carbon dioxide to try to pull that pH back into the normal range. All right. As always, please feel free to share and send over your questions.